Greetings. Hello everyone, this is a project presentation for XJCO2121 data mining. I'm Zixin, the presenter today. I will illustrate my project following the famous CRISP data mining cycle from the following 6 sections. The first section is about business understanding. Basically, the objectives of business understanding is to learn Weka and to complete the task in a specification. Or rather, we need to take full advantage of the Weka to optimize our model. In this process, we made clear criteria and action plans. Next, let's talk about data understanding. We follow the standard 4-phase approach. We find our data source authoritative. We describe the data comprehensively. We explore the data from the angle of files and attributes. Hopefully, it meets the requirement of quality. Based on previous analysis, we develop a general expectation for our model. Here comes the most exciting parts. Let's get our hands dirty and start to deal with data. An interesting fact is that we find every task unique and requires independent consideration. So for this work, we treat each task individually and come up with 7 ways to clean the data. The first step is just to extract the tweets. Then let us expand contractions, can't we? That means let us expand contractions, cannot we? Well, it's just generating the full expression. Here comes an important step, that is extract stems and normalize words. Stem is a tiny unit in language. By doing so, we could let a model to pay more attention in one word chunk rather than letting the model look at every word in the word family. Also, we remove some irrelevant words without emotional semantics. This allows the model to narrow down the scope of interested area. Well, the next methods are just very trivial. They are very normal strategies. We remove emojis, tags, user URLs, we remove quotations, we remove punctuations, and finally we load them into Weka and use the word-to-vector procedure to transform. From this slide, you can observe the difference between 2 datasets. After 7 steps of processing, the dataset becomes more clear, isn't it? After data preparation, we now do the modeling. In this stage, I actually often say no to what I have done and often do some repeated work. I tried several favorite classifiers with optimized parameters. For example, I tried 3 in a Bayesian string, and I tried the standard J48 but with elevated parameter setting. I tried the tree, the 0R as baseline, and it's so sad to admit that 2 classifiers that I like could not be used in this project for specific reasons. Finally, the most rewarding moment comes. It is time to evaluate our model. Well, we evaluate our model just based on the result in a test set. We set multiple metrics and have tried to output evaluation content. For task A, the best classifier is random forest. It achieves a F-measure rate of 87.3%. Task B is very special because the instance ratio is very imbalanced, so it's really tricky. I think both the random forest and Bayes logic regression becomes the winner, as the later one consumes less time but still reserves excellent metrics. Task C is rather easy to understand, and the Bayes net stands at the top. Well, this is just the end of the presentation. I really want to say thank you, Python, thank you, Weka, thank you, Professor Zhu Yan, and thank you, Eric. I really enjoyed the course. Thank you.